So starting out, I'm going to simplify what's inside the parentheses, right? The cube applies to the whole thing, to everything inside the parentheses. But I realize that I can simplify what's inside the parentheses first. So I'm going to do that. Now the 6 over 3, those both have positive 1 exponents. And I can do 6 divided by 3 and get 2. So I'm going to start out with 2 over 1. I'm just going to rewrite these for now so that we're sort of showing a step-by-step approach. Now the next thing I see inside the parentheses is the quotient rule on the ends. We're dividing with the same base, so we subtract the exponents. 2 minus negative 3. Now we have to remember that 2 minus negative 3 is the same as 2 plus 3, which of course is 5. So I'm going to get 2n to the 5th. Now, the only thing that's in the denominator is a 1, which we know we don't have to write, so I'm not going to write it. 2n to the 5th, and oh, by the way, the whole thing is still being cubed. Now I use the power rule. Now the 2 has its own exponent, it's a 1, so I have to raise the 2 to the 3rd power, and the n to the 5th to the 3rd power, which would make it n to the 15th. 2 to the 3rd is 8. So I simplify to 8n to the 15th. Now it might be helpful, as you're sitting there, to write down some notes for yourself. Something like this. So the first thing I did was I did 6 divided by 3. Then I used the quotient rule on the ends. Then I used the power rule. And then I simply did 2 cubed, which is 8. So these notes can be helpful because just hearing me explain it once doesn't reinforce it very much. But if you jot down these notes for you, then you can see those notes over and over again. All right, so we're going to revisit number 12, but we're doing it differently now. Okay, so what you just saw was one way to do it. Now, let's say that you see the power rule first, which means everything inside the parentheses is being raised to that 3rd power. So we need to raise everything inside of that parentheses to the 3rd power. So that would be 6 cubed n to the 6th, because the power rule says to multiply. And then it would be 3 cubed, and that would be n to the negative 9th. All right, so the next thing that I'm going to do is I'm going to simplify the 6 cubed over 3 cubed. Now, 6 cubed is 216. 3 cubed is 27. 216 divided by 27 we know is 8. So I'm going to get 8n to the 6th over n to the negative 9th. Now we're going to deal with the ends. And you can deal with this multiple ways. Some people, as I said, might see this as the quotient rule. And they might subtract the exponents. And 6 minus negative 9 is 6 plus 9, which is 15. Which means they would end up getting 8n to the 15th right away. Now, other people might see this negative exponent right here and say, oh, I should take the n to the negative 9 up top, where it becomes n to the positive 9. And that's okay, too. Then you get 8n to the 6th times n to the 9th. Now you have to use the product rule on those ends. And you have to add the exponents. 6 plus 9 is 15. And we end up with the same answer, 8n to the 15th. So we see there probably 3 different ways to do this problem and still get it right. And I've said this before, the easiest way is whichever way you see it. So don't get caught up in, oh, am I doing this the quote-unquote shortest, easiest way? Because whatever way you see is the shortest, easiest way. All right, number 14. So the first thing I see is b to the 0. Right, that one always jumps out at me, and that's probably the only instance where I can say it is safe to always make that your first move. Anything to the 0 power is 1. Right? So in a sense, that is canceled out. All right. So now I have 56a to the negative 4th over 8a to the negative 8. All right. Well, let's deal with this. 56 divided by 8. All right. So we have 7a to the negative 4th over a to the negative 8. And now, even though I see 2 negative exponents, I could flip both of those and they would become positive. But I'm just going to do the quotient rule first, right? I'm dividing, I have the same base of a, so I'm going to subtract my exponents. Now, negative 4 minus a negative 8 is negative 4 plus 8, which very nicely comes out to be a positive 4. So this comes out to be 7a to the 4th. All right, number 22. So again, first thing that jumps out at me is e to the 0. Anything to the 0 power is 1. All right, so now I'm going to have just 3 raised to the negative 3rd, right? I could write it like I just did, but I'm going to write it like this. 3 raised to the negative 3rd. The parentheses just means I'm still multiplying it by all of this other stuff. Now, over here, I see the negative exponent right there. So I might as well flip that to the bottom. But don't flip the 5, because the 5 has its own positive 1 exponent. All right, so there's where I am. Now, the next thing I see is this negative exponent. So I better flip that. So I'm going to have 5. Oh. Now notice how, again, I'm writing that 2f because up to in line with the 5 like that, because I'm going to end up multiplying. Right? I recognize that that's really like 2f over 1. And now this is going to become 1 over 3 cubed. Well, 3 cubed is 27, so I'm just going to make that 1 over 27. Now I'm ready to multiply. So I'm going to multiply my numerators. 5 times 2f times 1 is 10f. And then e to the 5th times 1 times 27 is 27e to the 5th. Now I always have to double check if 10 over 27, if that could be reduced. In this case, it cannot. So I'm done. Okay, number 29. Again, first thing I see is j to the 0. That equals 1, so we'll just cancel that out. Then I have k to the negative 3rd raised to the negative 3rd. That's the power rule. I'm not even worried about those being negative exponents because I know I'm going to multiply them and get k to the positive 9th. Then in the denominator, I have the power rule again. So I'm going to raise j to the negative 3rd to the 3rd power, and that's going to give me j to the negative 9th. And now I'm going to have to bring that j to the negative 9th up to the numerator. So I'm going to get k to the 9th over, k to the 9th, j to the 9th. All right, number 25. So I'm going to simplify what's in parentheses first. 15 divided by 5, right here, of course, is 3. So I'm going to have 3d to the third over d to the negative third. It's all being raised to the fourth power. Then I have the quotient rule with the d's right here. So I subtract the exponents. So I get 3 minus a negative 3, which is the same as 3 plus 3, which is 6. So now I have 3d to the sixth, all still being raised to the fourth power. So now I have to use the power rule. And remember, the 3 has its 1 exponent. So I have to do 3 to the fourth power and d to the 24th power. Well, 3 to the fourth power is 81. D to the 24th power. All right, number 28. So I do see all the negative exponents, but I'm not worried about them yet. I see the quotient rule twice. Here I'm dividing with the d's, and here I'm dividing with the e's, right? So I'm going to apply the quotient rule first in hopes that some of those negative exponents take care of themselves. If they don't, then I'll deal with them. If they do, great. All right, so d to the negative third divided by d to the negative sixth. I subtract my exponents, and I get positive 3. I like that. D to the positive 3. All right, then I have my e to the negative third divided by e to the negative fifth. Oh, and so I subtract my exponents. That's the same as adding, and I get positive 2. So my negative exponents did indeed take care of themselves. I cannot multiply these together because they're not the same base. I have a d base and an e base, so I'm done. Okay, again, number 26, I'm going to simplify what's inside the parentheses first. And the reason that I know to do that is because I see the quotient rule with the y's right there, and the quotient rule with the z's right there. So if I can simplify what's in parentheses, then when I go to use the power rule with my 5 out here, it's going to be a whole lot simpler. So let's deal with those y's. Y to the first divided by y to the negative 2, that's the quotient rule. So 1 minus negative 2 is the same as 1 plus 2, which is 3. So this is going to become y to the third. Now the z's, that z has a positive 1 exponent. So quotient rule, 1 minus negative 2 is the same as 1 plus 2, which again is 3. That also will become z to the third. Now the whole thing is still being raised to that positive 5 exponent. So now I use the power rule. So I have to multiply my exponents. In each case, 3 times 5 is 15. So I'm going to get y to the 15th, z to the 15th.